Hello, welcome back. Now we'll go into the what are the different operators that we have in Java. So, what do you mean by operators? Firstly, right from the time we did basic mathematics when we were kids, we knew addition, subtraction, multiplication. Then we went into a bit details. And as we grew up, we learned about greater than, less, greater than, then there's less than, and all those kind of operators, right? Then we grew up a little more, and then we learn about logical operators, that is and, or. So in the same way, so all those operators are used in Java as well. Okay, so first of all is the arithmetic operators, then there is the unary operator, then there is assignment, relational, logical, ternary, bitwise, and shift operators. Okay, so let me just tell you the symbols. So in arithmetic operators are the basic ones which we are already aware of: plus, minus, multiplication, division, and finally modulus. Now modulus is something which is a bit different, which we are not very used to. In modulus, what happens is, what we do, suppose we are trying to divide two numbers, suppose 9 divided by 2. So what happens is, a modulus will give you the remainder. Okay, 9 divided by 2, if you're performing the modulus operation, it will give you a remainder 1, because 9 divided by 2 will have a remainder 1. Okay, if suppose it is 10 divided by 5, then the remainder will be 0, right? Then by modulus operation, you'll get the result as 0. Okay, that is arithmetic operator. The next is logical operator. Now, logical operator is basically and, or, and not. Okay, then the next is comparison operators, in which we have equal to, less, not equal to, greater than, less than, greater than equal to, and less than equal to. Then there is the unary operator. The unary operator has the increment, the decrement, then plus, minus, and the not equal to. Okay, sorry, the complement. I'm sorry. The next is the bitwise operator. Bitwise operator is very similar to the logical operators. Only in this case, what happens is, we are not taking the entire number into consideration. What we do is, we take the binary values of it. Okay, like the binary format of the particular number, and bitwise, from like MSB of one with the MSB of the other, it is mismatched, and the value of the and the or not, whatever operation is performed, it's performed, and you get the output. Okay, next is the assignment operator, and finally the ternary operator. So let's go into the details of it. The arithmetic operator, as I've already mentioned, are 5 different types, and these are some of the examples which we are very used to. You've seen how this works. Okay, so this addition, subtraction, multiplication, division, modulus, increment, decrement, addition, subtraction, multiplication, division, assignment, and modulus assignment. These will come into it. First of all, let's do a program. We'll understand the basic of arithmetic operators if you do a simple program. So what this is one of the examples. The other is, let's do it by ourselves. Okay, so first of all, the directory, let's check out, which is the, okay, there is one subtract program that I've done. So let's do that. Okay, so first of all, what we do is, we open the program and check out subtract. Subtract.java, and you see this program is out. So here, first of all, we're performing the subtraction operation. In this itself, we can check out all the different examples. Okay, so here what I'm considering first is, the value of A is 20, the value of B is 10, and then we perform the subtraction A minus B. Okay, yeah, and we want the printout. The printing is the printing of the output. The display of an output is just by println. Okay, this is common for all the programs. But one thing you have to make sure, that this plus C, okay, this means that you are bringing the value of C, and you want the output that we want is the value of C. Okay, this is how we run it. So let's save it. Now let's run it. What to do here is Java C subtract dot Java. Okay, the next is Java subtract, right? See, you're getting 20 minus 10 is 10 again. So now let's get back and let's make some changes into it. Now, instead of doing subtraction, let's keep it, we'll just multiply the numbers, okay? Make sure that you're not changing the name of your program, okay? This has to, your class name has to remain the same as that of your main file name, okay? So I'm not changing anything. It's just the internal thing which I'm changing. Okay, make sure you, even if you're making any corrections, make sure you don't change the name of your program. Then you go and save it. Now let's go back here. So when you're writing this program, you don't have to keep on typing. If it's the same lines, you don't have to keep on typing. You can just press the up arrow and the previous program will be shown. Okay, so then first Java C, then you go back here and see, you're getting the, although I'm not making any changes here, I wrote it sub only, but it has to be multiplication. Now let's do a modulus. Then you understand what a modulus is. Let me make a correction here. So what we do is we write suppose modulus, and the symbol of modulus is percentage. Here also you have to make sure it's percentage. Okay. So now we save as, okay. So now what we do is we go here, then let me first clear the screen, okay? It'll be easier for you to see. What I do is Java C, and it was subtract dot Java. Okay, then we write Java subtract. See, 20 divided by 10 is 0. Now what do I do is, let me suppose change these numbers. Okay, it's, suppose I'm writing 23, this is 15, any random number, and I'm saving it. Let's go back here, then with the up arrow I'm getting this. Then you see, oh, I did not change it there in the value section, in the print section, so that's why it's written this way. So okay, let me first make the changes here. 23, 15. Okay, so save again, go back here, enter. You see, 23 divided by 8, 15 is 8. What you get is you're getting the remainder. So this is one of I've shown you basically all the 5 Java programs. Now let's go back. Java arithmetic programs. Now let's go to the next one. So what is the next one? This is the relational operator. Okay. So relational means you're comparing, right? So comparison is always done between two variables. So it has to be either less than, equal to, not equal to, greater than, or greater than equal to. Okay, these are the 6 relational operators that we use in Java. So yeah, this is how it is written. Okay, this is the syntax: a equal to equal to. You can just write one single equal to and expect it to compare. It will not do that. You have to give 2 equal to. 1 equal to means a equal to b. That is when you are assigning it. But when you want to go for comparison, you have to use 2 equal to signs. Then the next is not equal to, greater than, less than, greater than equal to, and less than equal to. This is one of the programs. So let's see what we can do in write our own program. So let me first clear the screen. Sorry, CLS. So now we are going to do a program which will have the relational operators. So for that, let me first see what's there in my directory. So here there is this statement called if2. Okay, so this is one of the comparison statements. So let me first clear my screen, and now let's open the program. Notepad if2.java. Okay. You see here the program. So what we are doing is here, So when we're comparing, you usually end up using an if-else statement. So if-else statement, basically what it does is, within the if clause, you'll see we are giving what the statement which we want to run. In this case, we want to see if x plus y is less than 10. So if that is the case, then it will print this particular statement like x plus y is less than 10. If it is not the case, then it will go to the else statement and it will print x plus y is greater than 20. Okay, this is how an if and else statement works. In the subsequent modules, you'll learn in details about an if and else statement. For now, this is just a basic understanding. And usually for relational operators, we use if else statements to explain if this is not the case, then the other run the other statement. Okay, so let me first save it. Now let's go here and write Java C space if2 dot Java. Okay, then Java if, okay. See, x plus y is greater than 20. Now let's go back to this and let's change the values. Okay, say it's 1 and this is 16. Sorry, it's still be, okay, let it be 8. Okay, so we are making it less than 10. Let's see. And so in the first case, what happened is it ran the else statement, x plus y is greater than 20. In this, if my calculations are correct, the if statement should be run. Okay, the first statement. So let's go back. Enter. Enter. You see, x plus y is less than 10. So this is how you run. This is how you do a Java relational operator. At the same time, you're also seeing the basics of an if and else statement, which again you'll be learning in much details in the upcoming slides, in the upcoming modules. Okay. So next, this is one of them which we learned about. This is a greater than or less than. So in the same way, you see here there is the whole set of program here. You can see this here again. You can see that it is run. It is using if else statement. You see, if A is equal to B, then A and B are equal. Else A and B are not equal. So this way, what you can do is when we are trying to practice the programs, you can take this as a sample, change the numbers and the values, and you see whether you're getting the desired result. Okay, in that way, unless you perform the experiments by yourself, you will not be able to understand how it works. Okay, so this is one of the way of doing it, and here it's a beautiful example in which all the different relational operators have been displayed and for your understanding. Okay, so next let's go to the logical or conditional operator. Now, what do you mean by logical operation? So logical operation has there are three kinds of logical operation. One is logical AND, logical OR, and logical NOT. So logical NOT is very simple. It basically means the complement, the opposite of it. Okay. Next is logical OR, and the logical OR and logical AND. So for that, you need to have some basic understanding of how AND and OR works. So logical AND operation, it happens, the result comes out in this way. If both the outputs are positive, only then it will give you a true output. Okay, so if both are 1, then only the output is true. If any of the inputs are 0, then the output is also 0. Okay, for OR, it's the reverse. If both the outputs are 0, only then the output is false. For any other condition, the output is true. Okay, and NOT, as I mentioned, it's the opposite. If the answer is true, it will complement it, and it will give you a false output. Okay, so here again, this is a logical operation. Here you can see that what we are doing first is A we are considering to be 5 and B is equal to 10. So in this expression, in C, what kind of an expression does it look for? It is asking if A is greater than 10 and if B is less than 20. So you can see here itself, the very first equation, that is A greater than 10, is not true. 5 is not greater than 10. So that means this expression in here, it's becoming false, right? So 1, 0 and with positive, B is less than 20. So this is true. But when you AND it, you are going to get a false output. Okay. Similarly, for when you're trying to check the or output, you see the same expression, but when it is OR, you can see that although A greater than 10 is false, but since B less than 20 is true, it will give you a true output. So that is how and OR works. And as for NOT, you can see that NOT is directly, it's complementing. The value of B is true, right? But since it complements it, it will give you a false output. So that is how a logical operator works. Let's see what I have for a logical operation. First, let me do a CLS, leave the screen, and then let me check in my directory. So I do have logical expressions. So what I do is, let me open in the notepad. Logical .java. See, this has opened. What I'll do is I'll just clear my screen and we can see how it works. Okay. So logical expression. You can see here what I'm considering is I'm instead of calculating the values and doing addition, I'm just going for a very simple program. Here I'm considering A to be 10, B to be 5, and C to be 20. So here what I'm checking first is if A is less than B, okay, and if A is less than C. So I'm trying to AND it. Okay, so when I'm actually in this case, I'm not doing the OR operation, I'm just checking out the AND operation, all right. So here, once I do it, I need the output. So let's check out what the output is. First of all, let me save it. And let's go back. And it is Java C logical X Java. Okay. Java logical X. Okay. You see, both of them are coming false. Why both of them are coming false? The reason behind it is the last expression is actually a bitwise operator. You can ignore this for now. We will get back to it later. So this is this is the just check the first one. Okay, this one is not required for now. Okay, I can make one change here. Instead of doing this, let me make it an OR operation. Okay, let's check what the output comes out now. Save. Let's go back here. You see, one is false, the next is true. Why is this coming? You can check it from here itself. See, A is less than B. This is false, but A is less than C. This is true, right? So we are getting one false and one true. And in case of an OR operation, if even one true output is there, the value will be your output will be true. So we are getting a true. But here, in case of the AND operation, you can see since one is false, obviously the whole expression will give you a false output. So this is how you do AND and an OR operation. And you can just for a NOT, you can just write. Okay, let's do this. You can just copy and paste, and just what I do is we can just write the wait, hold on. For NOT operation, what we can do here is we can directly so if you're considering even one of them to be true, so then the output of this can become false, which we have seen in the previous expression, right? Here we have seen, but here we are not assigning any values, right? For this, we can do the same thing here as well. We can do the same thing in this expression as well, but for this we have to assign a variable to this entire expression. So let's not get into that. It is the same thing. You can go back to this your example which is given here, and you can do the operation. Okay. So next, let's move to the next bitwise operation. So in bitwise operation, what we have to make sure is that we have to see, uh, we have to change the value of each of the bits of each of the particular number into this binary format, and each of the bit is made the and or operation is done based on each of the particular binary bits. Okay, so this is how you do it. So first of all, see here we have three kinds of operator. First is and, or, XOR, and bitwise complement operator. So here you can see, first of all, we are doing a bitwise and. So we don't consider it, we don't you see here 5 and 2, and you're seeing here it is written A and B. Here, since we're using a single AND operator, what we do is we convert. So in case of 5, it is 1 0 1, and for B, which is equal to 2, that is its binary value is 0 1 0, right? So you have to do the binary out. So when you are doing the binary output, the AND operation on 1 0 1 and 0 0 1 0, you see none of the values are actually true. Like both the values are not coming out as 1, right? They're all 0 0 0. So your AND output is 0. But in the same thing, when you're doing an AND operation, you see 1 0 1 and 0 1 0. What it does is, when you're doing an AND operation, you're getting 1 1 1, which is the binary equivalent of the number 7. Okay, so you see your output here is 7. Okay, in a similar way, you do the XOR operation, and then comes the here in an example, you see there is the right shift, left shift. So these operations, what happens is, in the right shift, the value of one of the suppose here they're considering A, right? So the last bit is moving, the LSB is moving to the right by one number, and in the left shift, the MSB, that is the max, the most significant bit, is moving to the left by one bit. So overall, the value, you can see when you're moving the value of a LSB, then what happens is the value goes to the lower value, right? It's moving towards the right. Okay, and when you're doing the left shift, you're taking the next bit, right, the higher bit. So obviously the value of the overall value of the bit increases. So you can see here, when there is a right shift to the value of 1, so when you're moving 1 0 1 1 to the right side, so obviously what happens is the one number goes away, then you're getting 1 0, which is equal to 2. And when it is the left shift, for the value, the same value, you're getting 1 0 1 0, whose binary equivalent is the number 10. Okay, so you see you get the output as 10. Again, for the right shift, when you're using these three right shift arrows, what this means is, this is for unsigned. Okay, there is something called signed and unsigned. So in the first case, that is for the signed bit. So since we are using a positive value, it does not matter. In case you use a negative value, then this signed and unsigned bits come into consideration. So if the value is positive, both your right shift and a unsigned right shift will give you the same value. We don't have unsigned left shift because the value does not change whether it is for left shift. It remains the same. Okay, so this is one of the operations. This program is already here. You can try to see how your work, you try to perform this experiment by yourself, and you try to perform this program by yourself and check out the outputs. You can also check the values by changing the value of your integer. You can try it with negative numbers, and then you see whether you're getting the desired output. Okay. Next is the shift operators. So I've already explained the three different types of shift operators in the previous slide. The same way. So here you can see how it is explained in a very nice way, how you're doing a shift operation. So you're converting the number. Okay. So when you do a left shift, the first digit, it moves. Okay. It moves to the one bit to the left, and the last, so once it moves to the left, then the next digit, the last MSB becomes vacant, right? So now that is filled with a 0. Okay, that's how you get this value. Okay, then there's a right shift. If it has in the right shift, what happens is the first value, if it is a 1, it is considered a negative number, and then it moves. You shift it, and then you get this value. And for an unsigned bit, the last value is considered to be a 0. Then you shift it, and you get 1 0 additional to it. This is how the left and right shift works. And finally, this is a sample shift operator. So it is similar to the previous one. You can practice here, and you can check out how you're working with it. I will show how you run a shift operation. So let me go dir. So I have a shift operation. Let's see how it works. Okay. So so it is shift. Sorry, not bad. Shift.java. You see here I've done. Here it is. There's a basic explanation of how you're shifting it. See, this is a and -5. So I have done it with a negative number. So you can try this out. So let me save it. And let's run it. Okay. Java C shift.java and Java shift. You see, these are the different values. So based on what your example is, based on your values, these values will also change. Okay, so suppose I'm changing this to maybe a positive number, suppose 8. You see, these values will change. Save. Let's run it. You see, the values have changed. So based on how you want to perform your experiment, your programs, you can change the numbers, and you should try to learn these programs by actually performing it. Okay, only once you perform these programs, you'll know how it is working. In case of shift operators, then bitwise operators, try to start with smaller numbers. You know, whose binary codes are very simple to work with. Slowly you can go for larger numbers, and also try with negative numbers, because negative numbers, then the whole 2's complement and all that comes into the picture. So you will understand it once you try to practice it. Okay, so with this we end this module. So thank you for joining us, and we'll meet you in the next module.